All right, let's talk about combinations of functions, but let's get weird with it. Okay, what if our functions are what we call rational functions? Okay, these are both what are called rational functions, and they're called rational functions. The word rational really means fraction. Okay, so the function itself is a fraction. It's not that it has a fraction in it; it's that the function itself is a fraction, and in that fraction, we have variables in the denominator. This one happens to have one in the numerator as well, okay? But we're really looking at variables that are in the denominator, values of x down here. That's what makes these rational, okay? Now, we talked in a previous video about when you get a function that is a combination f plus g, really all we're doing is taking f of x and adding g of x to that, right? And when they're polynomials, it's not that complicated. But when they're rational, right, we've got to follow the rules of fractions here. Okay, so f of x is 4 over x minus 7, and g of x is 3x over excuse me, x plus 1. Okay, if I oops, sorry about that. If I put parentheses around these here, I'm gonna spare us right now. Okay, but if we put parentheses around these, there's nothing being multiplied in here. There's nothing with an exponent, so I wouldn't need the parentheses in the end with this problem. Okay, so do we want to write them? Yeah, we want to write them, but we don't need them. So I'm skipping that one step at this point. Instead, we're going to talk and look at this. Okay, I want to add these together, and I really do. I want to simplify this. Writing it like this is okay, but we really want this to end up being one function that is one fraction. Okay, so we're going to practice some fraction skills here, if I may, right? And I'm going to bring us back to what, like third, fourth grade, something like that. When you were asked to add fractions like this, okay, you need a common denominator, right? You should all be familiar with the concept of a common denominator. Maybe you remember working with this, maybe you don't. Okay, I'm going to give us the cheat code for this. If you need to add two fractions, no matter what they look like, okay, and we're going to be doing this in a pre-calculus course, and you're going to do things later on that look really weird. The fractions are going to look weird. Okay, so let's simplify it. If I want to add these, that means the denominators have to be the same. The fastest way to make these denominators is the same is to multiply them. So I'm going to take this 5 and I'm going to multiply it over here. But in a fraction, whatever I do to the bottom, I have to do to the top. So I'm also going to take this 3 and I'm going to multiply it times the bottom here and the top here, right? So this 5, and my picture here is going to get a little jumbled, I apologize, gets multiplied on the bottom and on the top, and this 3 gets multiplied on the bottom and on the top, okay? And what we end up with on the top is 10, the bottom is 15. Over here, we end up with 3 over 15. And now, since our denominators are the same, we can add these together, and we get 13/15. Please don't add the denominators. That we never do that. We just write it one more time, right? So again, if I could, okay, clean this up a little bit. You're going to take the denominator, you're going to take the two denominators, right? You're going to take 3, you're going to multiply it here, you're going to multiply it here, times 3 times 3. You're going to take 5, you're going to multiply it here and here, and the result of this will be the same denominator and then the numerators that we can add together, okay? We're going to take that same approach to this problem, but it's going to get weird, right? So if I want to add these, I'm going to take this denominator and I'm going to multiply it over here. But whatever I do to the bottom, I have to do to the top, okay? Then I'm going to take this denominator and I'm going to multiply it over here. Whatever I do to the bottom, I have to do to the top, okay? Now, when we go to actually start simplifying this, here's going to be my advice. The denominator, don't FOIL this. Leave it as x plus 1 times x minus 7, okay? So what you're going to have is this product here being the same as this product over here. That's a common denominator. It's really awful looking, but they are the same now, right? Now, conversely, in the numerator, we are going to simplify this stuff. Okay, so we are going to distribute the 4 into that binomial. We are going to distribute this 3x into this binomial. So we get 3x squared minus 21x. And then when we go to combine these into one fraction, which I can do, I don't write the denominator twice. I only write it once, right? Just like I did here. I did 2/15 and still ended up with a 15th. So I'm doing the same thing here when I add these denominators, right? I'm not actually adding them, I'm just writing them once. But I am going to add this denominator. Oops, sorry, I shouldn't do that. It's not a minus. Okay. I am going to add this denominator numerator with this numerator. Okay. And because it's addition, we have no issues. When we get to subtraction here in a second, we'll talk about what that looks like. Okay. But for right now, all of these terms don't change any of their values. So it's just 3x squared. Negative 21x and a positive 4x is negative 17x plus 4. Okay, so we end up with our function f plus g of x, and it looks like this horrible looking thing. Now again, when we get to here, okay, just as a reminder, we have to make sure that our denominator does not equal 0. So our x plus 1 and x minus 7, neither one of these can equal 0, right? Our zero product rule says not allowed to let this thing equal 0, because if this piece is 0 and I multiply it times this, the whole thing is 0. If I let this equal 0 and I multiply it times this, the whole thing is 0. So we set each one of those binomials not equal to 0 and solve. Right, by adding here, we subtract 1 from both sides. Here we add 7 to both sides. So we do have to exclude those values from the denominator. Right, keep that in mind. So there's a lot going on here. Okay, I would encourage you to slow this down, maybe watch it again one more time just to make sure you're getting all the finer points.